So this is for Unit 6. It's error analysis with rational equations. We are going to find the mistake and circle it after we complete this problem. So on a separate piece of paper, we're going to write down this problem. X squared minus 2x minus 3 over x squared plus 5x plus 4. So I'm going to start by factoring this. Is this factorable? Asking yourself what two numbers multiply to give you negative 3 and add or subtract to give you negative 2. So what two numbers multiplied to give you negative 3 and add or subtract to give you negative 2? Correct answer is negative 3 and positive 1. As a reminder, the only time you do not have to do bottoms up is when the leading coefficient is 1. Again, what two numbers multiply to give you positive 4 and add or subtract to give you positive 5? Positive 4 and positive 1. I use my own term, and I say this is compressed. It's my own math term. That means this fraction is not separated by adding and subtracting. And if you're like, I don't really understand, if I gave you this, don't write this down. Do you see how these two are separated by adding or subtracting? There's two fractions. This is only one fraction. It's compressed. It's only multiplying across the top, two groups multiplied, and two groups multiplied on the bottom. Okay, when it's in compressed form, we can go through and check to see if anything can be simplified or canceled out. Is there a group that is x subtract 3 in the bottom? Nope. Is there a group that's x plus 4 in the bottom? Cancel it out. Left with x subtract 3 over x plus 4. A common mistake I see students make is they go, oh, here's an x on top and here's an x on bottom. I can cancel it out. But remember, this is just not an x. It's a x minus 3. It's a group. And this is just not an x. It's a x plus 4. It belongs to a group. This is the final answer. Now go back to the problem. We're going to find the simple mistake. Okay, that looks right. That's good. That looks right. That's good. Okay, small mistake. Highlight it. Happens to just be a sign. The paper that you are writing on will get attached to the back of this. You'll highlight what's wrong. You'll do the full problems on a separate piece of paper and number them, please. I'm going to go through 3 problems with you. There's number 1. Does anybody have questions for me about number 1? Please look at number 3. I believe it's beneficial to not even try to start looking at what they did. So I like to just cover it up. It's also great practice for you because these are the problems you're going to have to be able to do on your upcoming test. Let me see if I can zoom this in to help. There we go. Please let me know at any point when I do this problem if I run out of space, okay, if you can't see it. So I'm going to start by going, all right, this is division. What do I eventually want to turn this into? And when you, bless you, when you change from division to multiplication, you take the back fraction that follows the division and you flip it. You take the reciprocal of it. So it's eventually going to look like this. You'd be surprised that this problem really is not as difficult as it looks. They just threw in a few extra things. So when I look at the numerator of the first fraction, I see a lot of x's. What is the maximum amount of x's that I can factor out of both terms? 3 x's, so x cubed. When you factor it out, you'd be left with x squared minus 4. I'm going to come back to that a little bit later. That should stand out to you. On the bottom, what multiplies to give you negative 2 and adds or subtracts to give you negative 1? Correct answer is x subtract 2, x plus 1. X squared minus 1 breaks into x plus 1 and x minus 1 in factored form. The denominator of the second fraction has a lot of x's again. What is the maximum amount of x's that you can factor out of every single term in this place? X cubed, and what would you be left with? X squared minus x minus 2. Now, I sometimes can get a little bit lazy, so this is what I have right now. But I see two things that I can still do more with. Louise, make sure to keep your head up. Thank you. What does x squared minus 4 factor into? X plus 2 and then I'm just going to put like a little cross this out. I don't want there to be any confusion. I still want to see it, but kind of cross it out. Likewise, x squared subtract x subtract 2. This trinomial factors into x subtract 2 and x plus 1. What multiplies to give you negative 2 and adds or subtracts to give you 1? Remember, they're equivalent forms. Okay. These are all compressed. I have 3 groups pushed together. I have 2 groups pushed together. 2 groups pushed together and 3 groups pushed together. So at this point, I can start seeing, can I simplify? Can I cancel anything out? So I'm going to start with an x minus 2 on the bottom. Are there any groups of x subtract 2 on top? Yes. Okay, cancel it out. Are there any groups of x plus 1 on top? Are there a certain amount of x's? Remember, it could just be like 1x or 2x's. Are there any x's on top that are singles? They're by themselves that I can cancel with x cubed. And in fact, there's actually an x cubed on top. So I can cancel all of the x's on top that are by themselves. They're part of their own group. Is there a group that is an x minus 2 on top? Nope. There's an x plus 2, but those are different. Is there a group that is an x plus 1 on top? So I cannot cancel anything else. X plus 2, x subtract 1 in the numerator, x subtract 2, x plus 1 in the denominator. And do not take time to FOIL that out. That is your final answer. Now when you're done, we're going to go back and we're going to find out where did they make a mistake. So with your partner, I would like you to take 30 seconds with your partner and try to find their mistake. Highlight their mistake. The 2 mistakes would be with simple sign errors. It should have been an x plus 2 in the numerator position and a group of x subtract 2 in the denominator. We're going to go on to number 6, and I'm going to do a little bit more work with number 6 so that you understand multiple ways to solve things. Again, I've already asked you to change the name from Jesus to Maria in this problem. So Maria and Raul work out solutions to equations. Before I go any further, remember in math there's often more than one way to do a problem and still get the answer correct, which is cool. So I'm going to show you 2 different ways to do this problem, but remember there could be a third way. All right, so Maria and Raul work out the solutions. Here's the problem we're going to work out. Raul gets 3 answers. Maria only gets 2 answers. They don't even tell us what the 2 answers are. We want to find out which one is correct. Should there be 3 answers, and Raul gives them to us, or should there only be 2 answers? So I'm going to go over 2 different ways to solve this. I'd like you to watch and write down the method that makes most sense to you. Would you agree that x squared is the same as x times x? Okay, so one way that you are most accustomed to doing this problem is to find a common denominator. What is a good common denominator? It would be x squared. So this is missing an x. Good common denominator. Cancel out the denominators. Write down the numerator and now solve. X times x is x squared. X times 1 is 1x equals 2. X squared plus 1x minus 2 equals 0. Okay, what multiplies to give you negative 2 and adds or subtracts to give you 1. Rios, were you all playing basketball? Just skipping math class for basketball? It's a good choice, Rios, but come on. So x plus 2 and x minus 1. Those are the two numbers that multiply to give you negative 2 and add or subtract to give you positive 1. Okay, so how does this work? Do me a favor right now. I want you to take, we talked about this in class yesterday. Did we do the two hands yesterday in class? Yes or no? Yeah. Okay, put two of your hands forward. If I tell you that your hands in this case are going to represent different answers, and when you multiply these hands together, you get an answer of 0. That either means your left hand is 0, or it means your right hand is 0. So it means either this is equal to 0, or this is equal to 0, if this portion is going to equal 0. So what is the answer for this problem then? It is x equals negative 2. The answer for this portion is x equals positive 1. Remember, we have to always check. Go back to the original problem. When you plug in a negative 2, will the denominator equal 0? No, it would be negative 2, and negative 2 times negative 2 is 4. So negative 2 or 4 doesn't equal 0. When you plug in 1, will it equal 0? You're good. Okay, this is one way to do it. I want to show you an alternative method. Right now, I would describe this problem as being compressed. There's only one fraction on the left and one fraction on the right. An alternative method that I want you to be familiar with is when the left side and the right side are both compressed, you can multiply. Cross multiply. 2 times x is 2x. X squared times x plus 1. Make sure you understand this even if you prefer the other method. Multiplying or distributing to get x cubed plus x squared. Moving everything to one side. In this trinomial, they all contain an x. I can take out an x, and I'm left with x squared plus x minus 2. That's looking very familiar to the other method we used. In the other method, we realized that it breaks down to x plus 2 and x minus 1. I'm going to call in 3 different students. There are 3 unique groups here. Carlos, choose one of these groups, the first, the middle, or the last. Go ahead. First, Carlos, what is the only number that you can pull out the x and replace the x with a 0, and this thing will now equal 0? Okay, what's the only number that you can substitute in for x, and this group now equals 0? 0. X equals 0, a solution. Emily, choose the middle or the last group? Last. What's the only number, Emily, that you can substitute in for x, and this group now will equal 0? Okay, and very last one, Kat? The middle? Minus 2. Remember, your last step in solving rational equations is to check. Let's go back and check. If you plug in 0, does it work? If you plug in 0 for the denominator, does it work? No. In fact, what do we call that? Extraneous solution, because it breaks the math rule. This does not work. We've already checked negative 2 and positive 1 with a previous method, and it works. So more than likely, Raul did his problem this way because he got 3 solutions, and in fact, he got these exact 3 solutions. But is Raul correct? What did Raul forget to do? Check for extraneous solutions. Is Maria correct? Are there only 2 answers? So for number 6, not only do you have to solve to see what the answers are, you have to go back and say who was correct. Maria was correct. And then your explanation is there are only 2 answers. And I'm going to write them down specifically, x equals 1 and x equals negative 2. Raul forgot to check for extraneous solutions. I identified who was correct, and I explained. You should have this down on your paper right now.